Okay, so we want to be able to find zeros. Finding zeros is the same thing as finding x-intercepts, or sometimes, remember, they'll call them roots. You'll hear a lot of math instructors say that, oh, these are the roots. But we're talking about zeros a lot of times when we talk about polynomials. They'll usually use either x-intercepts or zeros. But you take the function and set it equal to 0. That's going to be how you find the zeros. All right. We also know a little bit about how many x-intercepts or zeros there are in a function. Okay, so it says find the x-intercepts of, and they give us this function. At most, we can have 6 x-intercepts. That's the most we can have. All right, so keeping that in mind, we couldn't have more than 6. All right. Now, we're going to do this by factoring, and I think we did that in the last section as well. So I'm going to look at x to the 6th minus 3x to the 4th plus 2x squared, and I'm setting that to equal to 0. So you'll notice there's a greatest common factor of x squared. I'm going to factor that out. And then that's going to factor into x squared minus 2 and x squared minus 1. So again, working on our factoring skills. And then, let's see, a little more factoring here. We can go x squared and then x plus the square root of 2 and x minus the square root of 2. I wrote the addition one first. It doesn't really matter which one you write first. You can think about that. You could take this part of the equation, I'll write it over here, x squared minus 2, and I'm setting that to 0. X squared equals 2, so x equals plus or minus the square root of 2, taking the square root on both sides. Okay, the square root of 2 is a real number. It's approximately 1.4. But it's a real number. There's no I. Okay, and then we have this part that factors into x plus 1 and x minus 1. So that one happens to be the difference of squares. You can think of the x squared minus 2 that way, but 2 is not a perfect square. But anyway, we get irrational numbers there. All right, we'll look at all of those factors then that we have. So taking this first factor into consideration, x squared equaling 0, well then I'm going to get an x-intercept at 0. And then taking this one, I'm going to get an x-intercept. I don't want to write the x there. An x-intercept of minus the square root of 2. It's whatever makes the factor 0. And this one is going to be positive the square root of 2. And then this one's going to be negative 1, and this one's going to be 1. So remember we said we could have at most 6. It looks like we have 5 x-intercepts. So I'll scroll up just a little bit. So these right here are the x-intercepts. If they want them as ordered pairs, let me show you that real quick, because they might. So I'm thinking that some books like them just listed that way, some like them in ordered pairs. I'm thinking this book likes the ordered pairs, but I could be wrong. Sometimes they're not always consistent either. Okay, so we have 5 x-intercepts, okay? And we've listed them. So we listed them as ordered pairs as well. That's what the question asked for. They asked for x-intercepts. But I'm going to scroll up a little bit and talk a little bit about the graphing. Okay, so let's say we want to look at the graph of this. I'll just kind of draw some graph paper here. We know where the x-intercepts are, right? Okay, so we know there's one at 0, 0. We know there's one at negative the square root of 2, which is about negative 1.4, so like about there, and 1.4. And then we also know there's one, we know that there's one at -1, and 1. Okay, so those are the 5 x-intercepts we're talking about. Now, in this section, we're going to be building up our information so that we could graph something. We could graph a polynomial function. We know a little bit about the end behavior. The end behavior, well, we look at the leading term, right? So this comes from the last section. It's even. The degree is even. And the leading term is positive, you know, well, positive. I don't know if we want to say it that way, but we know that it's going to be like up to the left and up to the right. That's what the graph is going to look like. We don't know exactly what the graph looks like, but we know it's going to do something like come down here, come up here, come down here, come up here, come down here. Well, something like that, and then it's going to go back up, you know, something like that. Now, do I have the right amount of turning points? 1, 2, 3, 4, 5 turning points. Okay, so, you know, I can't have more than 5 turning points. So maybe it looks something like that. We're going to find out more exactly what it looks like, or not. I guess more exactly is fair to say. We're going to find out how to tell more things about what the graph looks like, but that kind of gives you an idea of where we're headed.